Thank you so much. All right. So great intros. Thank you for that. I'm Guatam. I'm a co-founder at Gitar. Worked at Uber previously as a principal engineer on the developer platform team. A lot of DPE stuff for 10 years. And my passion is to improve developer experience.
Hi, I'm Ameya, and I'm an engineer at Gitar. And as she introduced me, my claim to fame is deleting 500,000 lines of code. And I recently graduated from Oregon State, where I studied program analysis and code rewriting.
Cool. So we talked about code maintenance early on in the slide. The key takeaways I want everyone to take from this talk is that code maintenance takes a lot of time, and automation is key to actually get that under control. And it also showcase how we at Gitar have been thinking about code maintenance. And you can check us out at gitar.co as well, or scan the QR code. So talking about code maintenance, who spends I don't know, this is a metric that we have 30% of time on code maintenance. How many people agree with this number? Do you think it's more or less? Okay, I see some thumbs up. Okay, yeah. So it's like a very common thing that people do as their code bases grow and mature. Lots of security fixes, dependency management, dead code, feature flags, just non-stop. Just, security assigning you tickets and hey, can you clean up this dependency? And it's always like a catch-up game. And also just going through code review and implementing best practices. There's a lot of manual maintenance that engineers do today that also is not easily recognized or rewarded. And we feel like that is a big opportunity for us to go tackle. And the reality, however, today is that I think a lot of talks mention this at DPE. Teams are being asked to do a lot more with a lot less. And the platform teams, which I believe most of you probably are part of, are serving disproportionately larger product teams. So there's maybe one engineer to 20 or even 100 sometimes that you have to support, which means the only way you can dig yourself out of this hole is through automation. And that's really key for that. To be able to be efficient at that scale. However, when we were working at Uber, we noticed that a lot of the solutions available are not sufficient. They at most give you a nag, a flaky test happened, go fix it. Rarely someone goes and actually does the thing. Or they don't really integrate well into existing tool chains. So they might have a great UX, but it may not show up in your code review tool. So you have to go build some integrations or, we call it stitching up the developer experience, where you kind of make it look like one seamless thing, but it has seams at the end. You can see it. And a lot of the times, even if they do automate, they're not cross-language. So we'll see tools that are very specific to one ecosystem, but modern code bases are not just one language. How many of you have just one language in their code base here? I thought I would see someone, but okay. Usually it's back-end, front-end, mobile. If you do VR, like Meta does, there's a lot of stuff that you have to maintain across different platforms. So you need something that actually works across platforms. And doing it with those many constraints is a very hard problem. We found this out in Gitar as well. The reliability is very important because if you open automated changes that don't make sense, developers lose trust and they don't want to see more PRs from those tools. Accuracy is very important so you don't fail your builds. Coverage is important because you can't miss stuff, because that means that you might think the problem is solved, but it's actually bunch of stuff left around that you still need to go clean up. And also performance is important. You don't want these tools to take forever. You want to be able to quickly iterate and get feedback from them so that you actually get the value and are able to commit this into your main branch quickly. And to talk about why it is hard, Ameya is going to walk you through some example use cases.
Hey, Gautam, thank you for setting up the importance of automation. So why is it hard to migrate? I will now walk you through two test cases. The popular one, JUnit 4 to 5. I think this is a migration that everyone wants to do or knows someone who wants to do or has done it in past. So now if you want to automate a change like this, as you can see it on the screen, you basically update the imports, you update the annotation from run with to extends with, before class to before all, ignore to disabled. And you might be like, what's so hard to automate? I can just write a sed script and get done with it. Maybe, but migrations do get hard. Now look at this example. When you move from JUnit 4 to 5, the assert not null, the arguments get swapped. Now this gets trickier now, in your sed script. It even gets trickier when you have to add an import at the top of the file, because now you have to do this change and then add an import if it does not exist. It can be even a bit more difficult if you decide to move to the Hamcrest version, where you have to add the third argument, not null value, and you have to also do the imports for it. Obviously, by checking if it exists or not. It can get even more difficult. Like here in this example, this is a test that is expecting an exception. But now in JUnit 5, instead of the annotation, what you have to do is you have to use the assert throws API and use the exception as the first argument there and move the body of the method into the lambda expression, which is then passed as the second argument to the assert throws. And now you can see how it is starting to get more and more difficult. I think the ultimate difficult is like if you have like custom JUnit runners which are like using reflection. So you had the request API in JUnit 4 and JUnit 5 has this launcher discovery request, which requires a launcher, a listener, and you have to like put all the objects into one another and then get the same result out. So you can see how hard it would be to move from 1 to 6, from 2 lines here to 6 lines there. And I hope you guys understand the kind of expertise that is required to do these kinds of changes in practice and also at scale. And as Guatam mentioned, it has to be reliable, efficient, and so on. We also, another important task that we do as software engineers who maintain code is cleaning up dead code. So one case study for dead code cleanup are stale flags. So I think everyone here might know someone or might be using feature flags. So the thing with feature flags is that you introduce a feature flag when you want a new feature, but you soon forget that the feature has been completely rolled out to all your audience. And now you have the dangling logic in your code, which never gets executed in practice. Imagine if by accident that, that code path gets, executed. Like there has been an incident with one of the banks, the Night Bank, who lost like $400 million because of that. So it could get like very expensive, an incident like that. But however, cleaning up feature flags is also not simple. So let's take this very simple Android example where you have a Java interface with a new banner interface method. And you have a Kotlin client, which is using this new banner interface method and either displaying the new banner or the old banner. And at the bottom, you have the Android components, which are the banners themselves. Now, if I have to delete this feature flag saying that, okay, old banner is not available to anyone. And I've completely rolled out new banner. I would first go and delete the flag itself. Makes sense. But then I'm going to get compilation errors. So I have to propagate this value everywhere. So wherever it's used, I'm going to replace it with true. Then I have to fold this disjunction into a true. Then I'm like, oh, this if true else doesn't make sense. So let me remove the else branch. So you remove that. But then it's like, oh, now I have unreachable code because there's a return and then you have print and return. So you have to also delete the unreachable code. And then you find that, oh, now I end up with the unused code. And now you have to also delete the unused code. So basically it's like I'm morphing into a compiler and expecting all developers to do these kind of cleanups on a regular cadence is just like a drag on the developer velocity. So we at Gitar are trying to solve this problem. Oh, sorry. And the bigger problem is also that, you have to do it across many languages. You just don't have, like he mentioned, just not a Java code base. You'll have Java, you'll have Kotlin, you'll have a Go backend, you'll have an iOS app, and you'll have front end in JavaScript and TypeScript. And you might be using feature flags everywhere, and you might want to do the same process that I showed you earlier in all these code bases. Now this gets hard, right? Now, first I have to do a complex refactoring, and then I have to do it across many languages also. So at Gitar, we automate this maintenance. And how do we do it? We actually developed our own framework to write these kind of refactorings. So we created Polyglot Piranha. So Polyglot Piranha is a domain-specific language with which you can craft polyglot refactoring tools. So basically, in this DSL, you can write a program, and this program is your refactoring tool, which will work across multiple languages. I actively maintain it. And if you want to know more about the theory behind the cool tech, then you should please go and read the paper, A Lightweight Polyglot Code Transformation Language. And it was recently published at PLDI, which is the top PL conference. And yeah. So I was actually very successful when I applied this tool at Uber. We managed to merge 1,800 PRs, and half of them, or more than half of them, were cleaning up stale flags, and the rest of them were migrating from the code from PowerMock to Mockito, or doing some internal migrations for Uber's internal APIs. Our study found that more than 90% of the changes required no manual intervention. So we created a PR, and the developer just reviewed and landed it. So it was like a very reliable PR that we could create. It affected like more than 500,000 lines of code, deleted/migrated. And we estimate that that's like 29, equivalent to a team of 29 devs working for 6 months doing this work. Now, actually, Guatam is going to show you Gitar in action.
Thanks, Ameya. Woohoo! So, Ameya talked about how we did this back at Uber. You could obviously like work on the open source project and extend it to your use case, but that requires a lot of knowledge and a bunch of infrastructure. So we at Gitar took that tool, took it to the next level, made a product that you can basically use out of the box. So here you can see the JUnit 45 migration. We ran it on an open source project, Tornado VM. You can check out GitHub. It's migrated like a few thousand lines of code, did the Maven migration, updated the requires and the module info, changed all the assert statements. And this is done all through static analysis. There is no LLM involved in any of this stuff. It's all declarative. But there are cases where LLMs could be interesting, especially when you have very specific context of what's going on. The method where we saw previously, where 2 lines of JUnit reflection became like a very complex method. We do that using LLMs as well. But a lot of these are very precise and surgical. So when we do use an LLM, we know exactly which changes we made with LLM, which were done without LLMs. And then we're able to point that out to people so you can take a closer look. And this is just a PR that you can generate automatically for different migrations. We also automatically fix build errors. So one of the things that we noticed back at Uber was like, if you have a PR that comes up and it's red, it's never going to get merged because developers don't have the time to like, context switch, change to another branch, fix it, and push it up. So we try to fix the category of issues automatically as much as possible, like linting issues, formatting issues, code style, best practices. So it's green by the time the developer looks at it for review. You can also interact with it. A lot of the things that people complain about is like, hey, it's great that you gave me a PR, but what if I want to customize what it does? So in this case, you can see, I'll let it play again. We have a method that was detected as no longer being relevant because we cleaned up a flag. You could obviously just rename it as like, hey, let's go clean this up later once you verify. You can ask Gitar bot to then actually go delete that method or rename it to something else, and it'll do that refactor. This is all done in real time. You can add a comment, it looks at it, you refresh the PR at the top, and then you see that now that method is renamed. And we thought like, let's shift all of this stuff to the left. So we also have IDE support for VS Code, JetBrains, where we have a language server that's running that's completely local, no access to the internet. You can also do these cleanups completely locally because we have the core engine is completely deterministic. So as I mentioned before, modern code bases are polyglot, which means they use many frameworks, and Gitar works across a lot of different languages, understands frameworks like your dependency injection, your test framework, and works on large scale repositories. So we're very language agnostic, can work with any code base size. And we also integrate with deeply integrate with a lot of tools in the ecosystem, which is your static analyzer tools or your IDEs or your source control systems, and make sure you get the PR. So our output is always like a PR that you can actually view and merge. And as I mentioned before, like the AI that we're using currently is based on a strong compiler foundation and framework intelligence for each particular framework and the rules and semantic rules in that framework, which means that whenever we do make changes with AI, we can explain it really clearly, and it's easy for us to like revert and make it completely optional for teams that may want like more guarantees about the output. So takeaways again, just to reiterate, code maintenance takes too much time. I think a lot of people agree automation is key, but it's very hard to do at scale reliably and efficiently. And Gitar takes care of a lot of this code automation. So if you want to come chat with us after, please reach out, or just we'll be around after as well. So you can come talk to us. And we have time for a few questions.